right, welcome everybody. Welcome to the AI or applying AI to manufacturing. I'm Lucian again, and I'm the host for today. I want to just a couple of reminders in there. So feel free to engage with the speakers. This is a live session. We've been running throughout the day and we'll be running for the next day or so. The Q&A is where you want to post the question that we track. So we do our best to answer all the questions within the 1 hour that we have. But then whatever we don't get to, we're going to create either a blog post or a respond to you directly via email. So Q&A is where we want to do that. We also incentivize folks to post questions there, as well as invite you to be part of the community. So with that in mind, the chat function you can leverage to expand on what are you working on? Perhaps if you have more details around, you want to add more details about your projects, feel free to leverage that. Tell us where you're from. I'd like to introduce the moderator for today. There's a lot of different perspectives. So we have influencer, we have end user, we have solution providers or vendors in the session. So I'm looking forward to it. So Jeff Winter is our board of advisors and the moderator for your session. Jeff, welcome.
Well, thank you. So hello, everyone. My name is Jeff Winter, and I'm an industry executive for manufacturing with Microsoft, and I'll be the moderator for today's session, Applying Artificial Intelligence in Manufacturing. Now, those who know me, they know I love the topic of artificial intelligence, and I can honestly say it's one of the single topics that fascinates and intrigues me the most, and it's mainly for two reasons. First, AI is extremely versatile in its application. It spans every industry, every function, and nearly every role, from entry level all the way up to the CEO. And second, AI has this mysterious science fiction allure that captivates people's imaginations and curiosity. So I'm excited for this topic. Now, joining me today, I have three panelists who are well-known and well-respected in the industry, yet each come from very different backgrounds. Now, in preparation for the session, we actually got together a couple times to kind of coordinate everything. And I can say that not only do they really know their stuff, but they're also a lot of fun. So with that being said, I will introduce them. First, we have Tim Linsenmeyer, and he is the CTO of Clover Imaging, a global remanufacturing company. And he's joining us from Hoffman Estates, Illinois. Next, we have Antonio Hill. He is the head of manufacturing digital solutions at Stanley Black & Decker and supports digital transformation by augmenting and amplifying the workforce on the shop floor and throughout the supply chain. And he's joining us from Mansfield, Texas. And last but not least, we have Rita Wuhabi, and she is the senior AI principal engineer at Intel, where she leads the definition of edge AI architecture. And she is joining us from Portland, Oregon. So we broke out our questions for today's session in three main topic areas. First is AI in manufacturing today. Second is challenges and best practices using AI in manufacturing. And third is the future of AI in manufacturing. So let's start with our first topic, AI in manufacturing today. And I'm going to kind of set the stage. So one of the things about AI that makes it so exciting yet difficult for people to grasp, at least in terms of how you maximize its capability, is really in the way that you think about AI. So the idea of replicating human cognition has been discussed and sought after for thousands of years, which means artificial intelligence isn't really a product. And you could argue it's not really a technology, and it in itself isn't an invention either. I mean, there's no real day we can attribute to its beginning and probably won't be until its end. So I would describe it as more of a quest, a journey striving towards the goal of replicating human intelligence. And it's constantly improving, expanding, and changing. So today, it's showing up everywhere in our lives, mostly driven by advancement in other technologies such as computing power and cost of computing resources, the internet, data collection sensors, and most definitely the development of different types of machine learning and deep learning algorithms and models. But what makes AI different than most other Industry 4.0 technologies is its ability to harness creativity and imagination. The sky's the limit on what it can do. So let's talk about each of your personal experiences and your company's experiences so far with artificial intelligence. And for this round of questions, I'll be asking mostly the same questions to everyone. So Tim, we'll start with you. Tell us about your journey and your company's journey with artificial intelligence. When, where, and how did you first start to use it?
Jeff, we started using artificial intelligence in 2017 to help manage our supply chain. We used predictive analytics to forecast what we were going to sell, predictive analytics to help forecast what we're going to manufacture and when, and using predictive analytics to where we need to stock our product to ship it to the user in the least amount of time. We used custom vision for inspection, quality, and cycle counting. Just take a picture of the bin and custom vision will calculate how much is in the bin. And then we use speech recognition so we can enable adult with disabilities speech challenges to work in our warehouse effectively.
And out of curiosity, how did you decide which one to start with?
Well, we had inventory challenges as a manufacturer or a remanufacturer. If your forecast isn't right and you're manufacturing to the forecast, you're making a lot of extra product that you don't need, and that uses up raw materials, it uses up labor, it uses up cash. So that was our biggest opportunity. We got buy-in from the organization that was our biggest challenge, and which I highly recommend, get buy-in before you start, but get buy-in to what your biggest challenge is, and then we threw predictive analytics at it, and we were very pleasantly surprised by the results.
Well, great. So Antonio, I'll ask you the same question. Tell us about your personal journey and your company's journey with artificial intelligence. When, where, and how did you first start to use it?
I would say that it started around 5 years ago with the addition of a CTO. The CTO that we added is a very established individual when it comes to technology, went to the Air Force, has background in that, and a fine human being. So with that, establishing that we're going to move in that direction, like by adding that position from a technological standpoint, some of the things that we obviously started within our organization was machine learning, where we use predictive analysis like Tim. The same with visual inspection, parts going through, we're identifying them and seeing non-conformance, and then able to kick them out and establish some data points from that standpoint. So that's really some of the ways that we used AI currently in our organization.
Now, you mentioned bringing in your CTO 5 years ago, and that's kind of where this started. I'm curious, does that mean AI was something intentionally sought after by the CTO, or did it just kind of happen to fall in place with a whole bunch of other things that were being worked on?
Great question, Jeff. So it was intentional. So it was placed on our roadmap in order to attack it. So that was something that he identified.
Okay, good. So Rita, same question to you, but from the other side of the fence. Tell us about your customers' journeys with AI, and where did you personally first start to use it?
Yeah, no, thanks for the question, Jeff. And I actually have to tell the audience, if you were expecting I'm going to tell you about Intel manufacturing, I'm going to disappoint you today. I know nothing about Intel factories, but I work with our customers, and our customers are OEMs and ODMs, as well as end users, factories. And I have been very lucky in the last 6 years. I came from a data science background. So many factories opened their doors to me and share it without boundaries so that we can help them use AI to solve some of their problems. And what was fascinating to me coming from an AI and data science perspective is that AI starts really and is powerful where the human brain cannot go. It's interesting, when you started, you talked about AI and the mystic behind it and all the science fiction. And it's, we always think that AI is going to replace the human brain. In reality, no, it's complementary. It is finding patterns where the human brain cannot find patterns. A good example is some work we did with Audi a few years back in welding, and the curves they've been looking at and staring at, and they couldn't find where are some of the issues, and AI found them no problem. Yet in other areas, right, AI is still not smarter than humans. So really, it's where the human brain is not going, or where our capabilities as people, lacking. Inspection using eyes, there is research that shows it's roughly 60% accurate. That's not great. So when we start putting cameras and looking at the images, AI and cameras, they don't get tired. They don't need glasses like I do when they got old. Yeah, sure, the lenses might get dirty, but really it is about finding those patterns. And we find in factories, what was fascinating is it brings on multiple, if you will, vectors of AI. We have time series, the controllers spit out a lot of interesting data, and we have video by putting cameras. And as factories are getting more advanced and adding a lot of those sensors, it's a tsunami of data, and AI becomes a tool to make sense out of that tsunami.
I agree. That's one of the challenges of AI. So Tim, I'm going to flip it back to you. So we just talked about kind of where you started on this. Now I want to talk about where you've applied it most successfully so far, and what were some of the results that you've seen?
Well, as I said earlier, inventory was a big challenge for us in managing the supply chain. So we had to right size our global inventory. And when we used predictive analytics for that, we saw a 44% reduction, a 44% improvement in measuring our sales forecast. We were using an Excel-based system before, and we switched to an AI ML model, and we compared the last 24 months, and the machine learning model was 44% more accurate. When you have a 44% more accurate sales forecast, that means that leads into our supply chain, what to order and when to have it just in time for manufacturing. That helps manufacturing because now we can manufacture what the sales forecast has predicted. That allowed us to optimize the labor in our facilities. We've seen inventory reductions. We've seen manufacturing costs reduced. We've seen warehouse optimized. In 2017, we were picking at a rate of 17 items an hour. An item is a line on an order. Today, we're picking close to 100, and we have less pickers. We have a higher employee productivity, and our customer fill rates are where they're supposed to be. And we attribute that to a very accurate sales forecast that we can take and feed into our ERP system.
That's an outstanding example. I'm curious, how long have you been running at kind of this optimized rate right now?
We started building the process in January of 2017. We went live in July of 2017, and we're still on it today.
That's awesome. So years.
It's been good. It's maintenance. You got to support it. You got to make changes as your business changes, but it's really helped our business. It really has, especially through COVID. That was tough.
That's awesome. So Antonio, same question to you. Where has Stanley Black & Decker applied AI most successfully so far, and what are some of the results that you've seen?
So one of the examples is in preventative maintenance. So using predictive analysis. So I'm going to say PM, which I mean in predictive preventative maintenance. So, I mean, I don't want to beat you over the head with acronyms, but some PMs are established in the industry and things that are known, right? And you have like a maintenance team that's going out and maintenance the equipment when they fall short, when they fail. So when this happens, it's more of a reaction standpoint where you would go out and your machines shut down, you go through, you assess, you figure out the problem, you fix it. So we were able to put some vibration sensors on some of our equipment for predictive analysis. One great example is that there was a time where our motor was about to fail. Because we were aware of it earlier, we were able to pick a really good time to shut down production, have maintenance go through and assess it, and get the repair so it continues to run and you don't have to actually stop the line, so to speak, in order to be successful. So this right here is probably a very strong example where you can see AI really taking effect into an enterprise in order to achieve its on-time and full delivery.
And that makes sense. And at least according to IoT analytics, predictive maintenance is the #1 use case, at least currently for AI in manufacturing. So Rita, where have your customers applied AI most successfully so far, and what results have you seen that you can share?
Yeah, so Jeff, you mentioned that, we got together and chatted, and you guys reminded me a few years back, and I was on a flight to China, and I would go work with, big, small, and medium-sized factories to figure out how AI can help them. And as I was thinking through it, it struck me that really AI is successful in one of two situations. It's either it's going to help a factory make more money, right? Somehow improve the quality, improve the yield, make it faster, make it better so that they can charge more for it, or save, right? And save not just money, also save individual. We see a lot of applications, worker safety. We've worked with factories where they were having, people getting hurt, and we put some cameras, make sure that they have their hard hat on, they're not getting too close to a robot, they're not getting too close to an area where they might fall and, get fatally hurt. So it's really about those two areas in two big buckets. And in them, things can be classified like defect detection, putting a camera to detect that something got a scratch on a product, or a product is not what you would expected it to be, or is not top quality, and detecting it as soon as it happens. Because sometimes, inspection used to be, again, another factory I visited that does textile, right? Does like the fabric that comes into nice clothing for all of us. And sometimes they would have oil spilling in one of the machines, and the way they inspected it, they had a bunch of people walk up and down the aisles because their machines were very old and they couldn't get the data. So we put a bunch of cameras, and as soon oil would start spilling from these old machines that are awesome quality, by the way, you don't want to upgrade them for no good reason, and it's a huge investment, the cameras would alert, would even pause the equipment, and you're able to have just this much of oil spillage on your textile versus, miles and miles literally of textile and fabric that they would have to recycle. So again, make money, save humans. These seem to be the big buckets where a lot of use cases that are successful fall under. Anything else is what I call science project. It might be fun to work on, but really is not going to cut it.
I like your way of kind of breaking it up and describing it. So let's switch to our second topic, challenges and best practices using AI in manufacturing. I mean, after all, if artificial intelligence were so awesome and easy to use, everyone would be using it everywhere, right? If only it were that simple. So let's dive in. Let's talk about this a little bit more. And Rita, we'll start back up with you. What areas or types of AI should you be looking at first?
Yeah, again, let's talk about, where the money is. Start with return on investment, right? And it is tempting to me, I'm a data scientist, it's tempting to me to start geeking out about the data. And I will do a little bit of geeking out about the data. But at the end of the day, it has to bring a return on investment. It has to be where you're solving a problem that matters, a problem that is hurting your bottom line. By the way, your bottom line could also be not just quality, but also reputation, right? This is similar to the Audi use case we worked on that Audi very generously went public about. Not only was it quality of the weld and quality of the car as a top tier manufacturing, they had the reputation on the line, the brand name, right? And, being part of big companies, we know how much the brand name matters as well. Now, once you break it down to, I picked something with a decent return on investment, everybody gets it, then it's time to start thinking, where do I deploy it? How do I go about this use case? Is it something that I can put in the cloud? Because, it's predictive maintenance. Within a couple minutes, I need to tell someone that this machine might fail in the next hour or so. I do have, a leeway. Or is it a robot that's about to scratch your car, your fancy brand new car, right? You need to stop it right there. You might have a couple of milliseconds as a max. So again, where you put the AI and what kind of AI, what are your sensors, how you're going to get to that data? Do you need to add sensors? All of those are really important in thinking how to approach your use case, what use cases to go after, how to approach them, and then who are the people who need to be part of this engagement.
I like it. Did you have any, I'm just kind of curious from your side of either specific types of AI or yes, specific algorithms or anything that you would kind of look to start at?
Yeah, absolutely. And whatever I'm going to say, I'm sure, some people are going to be happy with me and some people not so much. There are favorites. It's like, your favorite brand of coffee or something like this. It's bordering on that kind of favoritism. It all depends as well on the data. What kind of data do you have and how much data do you have? What techniques would you use? Just like everything else, AI is a tool in your toolbox. If you have time series, if you have data that the PLC or the PID controller is spitting out, then you're typically not going to go the deep learning route because you don't have a lot of data and this data is not labeled. You'll go a traditional AI method. You might look at KNN and random forest and a lot of techniques there and a lot of really wealth of algos. Good and bad at the same time. Good that we have a lot of techniques, bad because still some of them sound like a foreign language to a lot of control engineers and factory experts. If you have images, deep learning is your answer. And deep learning have become very, very pervasive and also very rich. And there are a lot of techniques that you could apply there. If you have data in deep learning, you can go the traditional route. You can look at your favorite network. If you don't have a lot of data, you might start looking at ways of looking at unsupervised learning or semi-supervised learning. These are areas that only requires a little bit of data and can start by giving you an algo or a model that you can deploy and test and refine, and they work more iterative. So again, it feels like it's a decision tree almost that you need to traverse on techniques based on the data, what kind of data, how much data you have, and so on. Hopefully we'll do better as data scientists. We'll make this decision tree much simpler in the future. But for now, there are a lot of options that you need to get familiar with at the beginning.
Well, I like that answer, and to comment on how you kind of kicked it off. Any good thought leader in the industry is going to put their opinion onto different subjects that aren't, typically black and white or right or wrong. And so, yes, there will always be fan favorites and others that people don't like as much. So I appreciate that. So we'll kind of switch then to you, Tim. So we just talked over like kind of where you can look and where you can start. For you, what are the major pitfalls in applying artificial intelligence or machine learning to manufacturing, and how can you avoid them?
Well, I wish I'd have had this event in 2017, so I would have learned all the major pitfalls in applying it, because we made a lot of mistakes, but we learned a lot along the way. A lot of the pitfalls we had was a shortage of AI talent. We had technical debt. We had legacy systems out there that were hard to support. We had to make sure the support from the organization has to be there across the board. And then there's transparency and trust with our users. So some of the things we did to address that, I strongly recommend you get buy-in right from the beginning. Going at it alone or just as an IT team at first is not recommended. I probably should have listened to my own advice there, and I didn't, but trust me on that one from a person who did it. We moved ahead, we forged ahead, and if I had to do it again, I would have made sure that it was a company-wide organization and we'd had much better support and implemented it a lot faster. That one is the most important one, but it worked out really well for us. Get the users involved early, continually train them and educate them, explain the process to them, tell them how it's going to help them. It's going to make them more productive. That helps you get support from the organization in testing. We involve users very early on in the process. We continually train them, we educate them, we explain the process, we share the results, we show the before and after. We broke it down in sales forecasting, we broke it down in manufacturing, we broke it down in the supply chain for planning and purchasing. We really educated our users, and then it became a company initiative. The hardest part was the shortage of AI talent. We partnered with a consulting company, and we had zero Azure experience, and we had zero experience in machine learning, artificial intelligence. And the deal we made was that they would help train us to do it. We would build it with them, and we'd be able to support it. We'd be self-sustaining, and it's worked out really well. We used the consultants the way they were supposed to. They educated us, they trained us, they were with us, they helped us test it, they helped us implement it. And our goal was to be highly self-supporting, and we are. Occasionally when there's changes and new technology come out, we need a consultant to help us, but for the most part, our AI ML model is self-supporting in Azure. The other thing that we learned, we should have leveraged the cloud. Back in 2017, it wasn't as predominant as it is today, but our legacy systems, we migrated them all to the cloud. And when we did that, that made it so much easier because AI and ML is running in the cloud. So before, when we did it, we had an on-prem solution that we had to read and write data to. And now everything is in the cloud, and it's very seamless to do. It's way easier to do today than it was when we did it in 2017.
Well, I appreciate the advice, and it's funny that you hear your first point that you meant get executive buy-in, right away is something that seems obvious when you know the answer, but as you're going through it, it's not quite as obvious, especially when you're experimenting with new technology that you yourself said you and your team know very little about when you started. So I'm curious to dive a little deeper into that one, your shortage of AI talent. What's something that you learned coming from ground zero, literally having no knowledge or expertise in artificial intelligence, and now your company is utilizing it very successfully on a regular basis? What's something you kind of learned along that way related to artificial intelligence as the technology, I'm going to call it, that you used?
One of the things that we learned was that our IT team was hungry for learning something new, and retention in IT talent is very hard, right? You can't just keep changing their title, giving them more money. You got to challenge them, and you got to give them projects that they can take and run with. And when we partnered them with our consulting company, I mean, they really took off, and they just became so involved in the process. They were so happy that we gave them that opportunity. We helped them learn the cloud with the consulting company. We helped them learn the AI and ML models that we were using for custom vision, for predictive analytics, for sales forecasting, for inspection, for quality. And so the team really took to that. And that was more motivation and retention than we could have ever done. And I think since 2017, we've lost one. So we're very happy. More with less is one of our core values, but getting that team involved and challenging them and pushing them and driving them, giving the opportunity to learn and learn from industry experts like the consulting company we're working with and from Microsoft. Huge win for us. Very made it very successful. And like I said, our costs were reduced because we're self-supporting, and that's a huge cost.
Well, I like it. Well, thanks for sharing kind of your learnings along the way. So Antonio, I'm going to switch to you. So we just talked about some of the major pitfalls and ways to avoid them. Let's now talk about the ways to take advantage of artificial intelligence. How do you even go about getting this internal adoption?
So what I would say that you have to start with is, what is the problem that you're trying to solve? So that's like what you're going to have up front and what's your objective. And for the most part, what concerns or opportunities that you have to look at. And that's why you're looking out for ways in the solution to do it. And then you're going to have your proof of concept that you believe that you can establish. And then the next one, which I think will be essential, is that starting area that you're going to focus on to go ahead and implement this proof of concept. Wherever it is, you just want to make sure that you have the right place where you can be able to get a quick win that's short and successful, depending on what that application is. And so from that standpoint, after the aftermath, I think that Rita said it earlier, is you're going to be looking at your ROI from that standpoint. So it's just reviewing what happened, and you're just documenting and beginning to standardize that approach of what are those key criteria of the way that you implemented that into that area that you focused on. And then from that standpoint, you're able to saying that it is a win, and I'm more than likely you should have some type of success in learning. Then you can extrapolate that out using certain key data points to basically uniform that across the rest of your facility. If it's one industry, I just don't know if you have an enterprise. You could have one manufacturing facility that you're just trying to scale it throughout the facility, but you want to be able to establish some of those metrics that you're going to be targeting and scale it out from that standpoint. Now, I will say this, that the people involved will be essential and very important, such what Tim suggested earlier. And so during that time, you definitely want to bring them around, let them see what's going on, and keep them heavily involved the whole way. What this is doing is this is get them used to, hey, this is for you, this is for our organization, wrapping their arms around it and saying, hey, this is how we're choosing to move forward with this new technology, And we want your opinion. We want you to weigh in. It's not something that we want to be able to create like in a bubble. We want your reaction because obviously those people that are closer to the process are more aware. So they probably know some of the problems as well. So for me, I think that this approach of getting that proof of concept and establishing it there and then reviewing the data that comes from it before scaling, and then obviously taking it up to, and I'm going to say something else that I believe Rita and Tim said, to leadership, because you're going to definitely need their buy-in before moving on and scaling. So that's going to be really important and essential.
Well, I think that cues it up perfectly for what I'm about to ask Rita, which is, what is the best way to scale artificial intelligence from your proof of concept to being a valuable deployment across the enterprise?
Yeah, actually, Jeff, I want to address two elephants in the room that we have. The first one is this idea that AI in manufacturing is going to replace jobs, right? And honestly, I tie that back to buy-in. It's not just the buy-in of the execs. And it was a humbling experience. I learned that the hard way. It's the buy-in of your experts. It's the buy-in of the boots on the ground. And I can use again, Audi as an example. My welding expert initially, I was like, well, AI, I'm an AI expert. I come with that arrogant baggage. It's like, just give me the data and I'll solve whatever problem you got, right? Well, a lot of us, unfortunately, do have sometimes this attitude, and we learn really quickly that that is not going to get us very far, because this is not classification of cats versus dogs that Google implemented and showcased to the world deep learning. This is different. And when I got the data for welding, my initial data, my initial accuracy for detecting defects was around 60%. That's super embarrassing as a data scientist. That's a smidge better than a coin toss. And that humbled me. I had to travel all the way back to Germany and hang out with the subject matter expert and tell him, hey, I'm gonna win you over. Tell me more about welding, teach me about welding. And in the AI domain, we're calling that data-centric approach. Rather than, hey, the algo is the king, let's throw more data at it. This is more, let's understand what is this problem that I'm solving. And that helped us to get to above 97% accuracy and stay there for the rest of the pilot. That also made that expert understand that AI is complementary to his skill set. And as a matter of fact, he went from, I don't want to be in the same room as her, to, oh my gosh, we're going to be best friends. Let's have dinner tonight. I want to introduce you to my family attitude, because you're complementing. So that's the first elephant. AI might perhaps change or replace some jobs. To a large extent, what I have learned is that AI needs to be humble, because AI is going to complement jobs in factories. Now let's talk about the second elephant in the room. Honestly, coming from a data science background, I remember learning about manufacturing and factories telling me, oh, we have one device by function, right? You want to do X, you buy a device. You want to do Y, you buy another device. And I looked at them, I said, this is crazy talk. Who does that? Who does that, right? Look at the cloud native applications. Look at what computer science have advanced, where it's like saying, I want to do Excel, I'll buy one device. I have Zoom, I'll buy a different device to do Zoom. No one does that anymore. So this is how you scale. You scale by thinking about going from one device, right? You're doing a pilot, maybe one device or one cell, or whatever is your unit, to multiple devices, to multiple sites, and then to multiple use cases. And you move away from this one function. You think about a platform, about how you're going to create a blueprint that not only solves this problem, but solves additional AI problems in the future, and you deploy accordingly. And what I also learned is that as we're doing the pilot with those different steps that I just talked about, I had to be thinking about the next step. So if we're in pilot mode, one cell, I had to be thinking, okay, how do we go to multiple cells? When we got to multiple cells, and it doesn't have to be me, obviously, it can be the factory. They have to be thinking about what is the next step. They have to be planning for the next step, so that when this first step is successful, they're not standing around looking at each other saying, oh, so what now, right? You have to be proactive about it to see that success. So buy in, proactive, think about your future, and plan for the future.
I like it. I like it. So let's say we're already kind of did our deployment and we rolled it out. Antonio, what are some of the ongoing challenges that you face once it's been deployed?
Great question, Jeff. So I would say that there's a barrier of complexity, or let's say a perceived complexity. So if I were to say we're deploying artificial intelligence to a group of people in the room, they're going to be like, ooh, ah, they're going to be thinking of, some type of robots or something of that nature. And so that's one. You're deploying something that is not necessarily easy to the layman individual. And then, so from there, you really need that champion in order to make that transition go over smooth. And so, for instance, I'm going to just use it like with Rita. She made me think about it earlier. She comes in and she's hoping to deploy out this new technology, and it's successful. But what happens when Rita leaves? So that's why that champion is not only important, but that champion's important to make and train other champions, right? Because you want to be able to establish in individuals to have agency, really a heuristic approach so they can own the process later on. So I think that that's what really that real challenge is that creating this where it's normalized, it's not complex, it's not difficult, it's not challenging. You can do this, and then documenting, standardizing, making it easy for them to sustain that change that you already know is a big win for your organization.
I like it. Thanks, Antonio. So let's go one step further for that of kind of the challenges. Let's talk about how you can evaluate the success of AI adoption after its implementation or as part of the implementation. Tim, I'm curious kind of what metrics you use for evaluating success.
Well, when we got the go ahead and we agreed that we were going to use ML AI to improve our forecast accuracy, we said, well, what do we want? Where are we at today? And what we found out was in 2017, we weren't doing a really good job measuring our forecast accuracy. We were just changing it from month to month to address the pitfalls that we had from an inaccurate forecast. So our first goal was to measure forecast accuracy. And what we did, there's a standard calculation for that, and ML actually provided it, the results. We took 24 months of our historical sales and forecast, the old forecast, and 24 months applied to the ML forecast. And like I said, the mean absolute percentage error is a statistical formula that calculates the accuracy of a forecast. And like I said, our machine learning forecast was 44% more accurate. But one of the things that we learned about AI and implementing it in the effect of our business is obviously you have to identify the KPIs, and you got to know what the ROI that you want out of it going into it. You can't look for it after. You got to know what you want to do, what problem you want to solve going in. And one of the things that we found out that every project that we put AI and ML on, it far exceeded any ROI that we had. And I'll just give you a couple of examples. You have to measure everything. And there's so many benefits outside of what you could plan for. Like, we wanted to optimize our warehouse. We wanted to improve employee productivity. We wanted to go from 17 items an hour to 50 an hour. Well, we're over 100 now. But what that meant is that now we needed less forklift trucks. And we didn't even calculate that into our calculation of ROI. Forklift trucks are $1,500 a month, and I think we got rid of 12 of them in one facility because we made the employees more productive, picking more, not needing forklift trucks. And we didn't even calculate that into our thing. We eliminated all overtime. We don't have any overtime in our facilities now because we know what we need to make, we know what we need to stock, and we know what we need to ship, and we know the labor appropriately for it. So again, KPIs before you start, ROI is going to far exceed your expectations. It goes that way today. We used to have a bunch of cycle counters, and now we don't have any cycle counters because when the picker goes to the bin, he just takes a picture of it before he picks any item out of it, and the system using custom vision will calculate it. We didn't even think about the opportunity and the labor savings and the labor optimization. So again, if I had to do it again, I would make clear, defined ROI and KPIs, and pretty confident everything that we did, it exceeded our expectations. But you got to get as Antonia and Rita said, you have to get buy-in, and everybody has to know what we want to get out of it. It's not just to improve productivity or to improve quality or reduce labor. You have to have clearly defined initiatives. And we probably could have done a better job at that. We're doing a really good job of it now. But anything that we do now, we have clearly defined initiatives, and we track it ROI. And then finance is very excited about us. They're very happy the impact that we're having on the organization by lowering costs and improving productivity. But at the end of the day, everything is measurable. You wouldn't buy a new machine in the warehouse. You wouldn't outsource something if you didn't have the ROI. You would already know. So the same thing with AI and ML. You want to implement that technology, build your KPIs, know the ROI that you want to get out of it, and measure it every step of the way, and share the results. Antonio mentioned it. You get people engaged, and they see the results. And we've done some crazy things with recognizing people that are going above and beyond and just doing really amazing things with the technology. We welcome ideas from our end users. You get everybody involved, and it's much easier to implement, and the results will far exceed your expectations as they did for us.
I like that. And I would actually have to say that part of this is what comes from experience with this, because not only did you generate ROI based off of what you anticipated in advance, you learned additional things that you should and can pay attention to for future projects through this, which just helped even further. So that's exciting to hear. So let's switch to our last topic, and then we'll have some time for Q&A at the end. So our last topic is the future of artificial intelligence in manufacturing. And even with all the advancements that we've had in technology, we're still nowhere really close to achieving the vision of artificial general intelligence. I mean, we've mastered computing and wrangling big data, but we're still trying to figure out the learning and the intelligence components. I mean, most people describe AI as in its infancy, the very beginning. And this means that where and how we use AI today will most likely not be where and how we use AI tomorrow. But what is realistic? What do we expect to see, at least in the relatively near term? So Antonio, I'll start with you. How do you see AI interacting with humans going forward? And how do you see it changing company culture?
I think that augmented AI is something that we definitely will have. I think that we should see in the future some of the autonomous AI of being able, I think that we've learned so much just from cloud computing, but being able to identify certain things when you see abnormalities or irregular data, and something that's irregular in the data. And then the next step is to take action. And so a lot of times that's what the human is doing. They see the data and then they take action. But I think that we'll begin to have more opportunities for the software to engage and actually take action, as far as soon as it's identified. And I'm just going to use an example just to level set. So in some manufacturing facilities, they have equipment that have auto feed and basically dispense that part. So the material comes in automatically into a CNC computerized numeric control machine, and then it's able to kick that part out. So the schedule of, let's say that it's making a widget apples. Let's just say that something happened where they were able to identify in the ERP system that the apple material will come late. So to be able to make a decision and saying, oh, you know what, we need to switch and make more of another product without any human interaction because it's the right thing to do. I think that is something that's on the horizon as we move forward, as we get the use cases and we start to establish some economies to scale. Because one thing that you can say that's really interesting when it comes to this space is that all of the successes that others have, you know, we all hear it and it normalizes it in a way for us to advance that even more. And I think that you'll begin to see us get closer to that end more and more as we evolve within our manufacturing facilities. And so I think that Moore's Law will obviously take advantage. And so really looking forward to seeing what's next in the future.
Awesome. And I like the idea of talking about augmented versus autonomous decisions as part of kind of the shift in AI, helping you make decisions or making decisions for you. And Tim, I'd be curious kind of how you see the shift from augmenting to automating decisions in manufacturing. And where do you think this will kind of be done next?
Well, with the challenging labor market, we have training, certifications, employee safety and security. One of our core values is do more with less, and we wanted to make employees more productive. So we used predictive maintenance, predictive analytics, and we forecasted the useful life of our equipment in the manufacturing line. So we could predict when they needed to have maintenance or when they were going to go down, because going down, a machine going down is very expensive. So again, we don't have to, we could do that off hours, and we really minimize our downtime. The robotic process automation, how to handle highly repetitive tasks that people were doing before, like quality inspections, safety and security. We'd have people that would look at the cameras and try to spot safety. Well, AI and ML can do that. Watch the cameras and alert people when there's going to be a safety issue, or security, inspection of a manufactured product, inspection of a quality product with computer vision. It really helps make the employee more productive, gives them opportunities to do more, to grow inside the organization, but it's partnering side by side with them. At the end of the day, we produce a lot of data, a lot of reports, and those data and those reports need to be reviewed by the people that are responsible for those, like line productivity, like quality, right? And ML will give us those results, and then we can analyze them and take it back and learn even more. So again, I like it's augmented with the human process. It's not replacing it by any means. It's not autonomous AI right now. We're using it to augment the human decisions, tell them what to look for, and have them work together with the data and the reports that we produce to keep the lines up, to keep productivity up, and continually lower our costs.
I like it. And Rita, we'll wrap up with you. What's kind of the biggest potential for AI to revolutionize the manufacturing industry?
Yeah, thanks, Jeff. This has been so exciting. I think we heard everyone talk about challenges in workforce, challenges in data scientists, how we're going to scale. And the way I see it is I'm going to turn, the light and shine it back at us data scientists. If we do our job and do it well, we will be here, or you will have a session in 10 years, Jeff, and you will not invite me because you will not be talking about AI. AI would be so pervasive and exist everywhere that no one even pays attention that it is there, and it's augmenting and it's helping and it's making things more efficient. I mean, today, if we were, in person and we're going to hang out over lunch or over drinks or over coffee after the session, I wouldn't sit there and say, oh, the other day my TV recommended a show for me and it was spot on. That collaborative filtering is so awesome. I mean, no one does that. No one even cares that it was AI that recommended the show to me. I would talk about, the show being cool and recommend it back to you. So if we are successful, AI becomes part of the toolbox that everybody uses, that the control engineer, the subject matter expert, the forklift operator would be using AI without thinking about it. It would be assisting them, and they wouldn't think, oh, which AI did I use? And what was the accuracy? And what was the ROI on it? All of these would disappear because AI becomes a tool in the toolbox and everybody just uses it. And the panel you would be running here, Jeff, it would be like, AI in my factory got updated in 1 millisecond. Why? It took you 2 milliseconds. I mean, those Intel and Microsoft, but gotta do a better job.
I like it. All right. Well, that wraps up our three main topics, but now we want to have the opportunity for the audience to ask questions for the remaining few minutes. So just so you're aware, we're not going to be able to get to all of them because we have 12 so far that I've seen. So maybe we'll try and do lightning round quick. Some of them are directed to people, some of them are just general. So I'll kind of start with one and we'll see who wants to chime in. Now that you've adopted AI for predictive analytics or preventative maintenance, what in your view is the next step? Will you adopt conversational AI or something like generative AI, GPT-3, to further empower frontline workers? Who wants to take a crack at that?
Well, I'll start. We use the easy ones first, the predictive analytics and predictive maintenance to help us solve a big problem with forecasting. And then we took it to every other pillar that we had, and with the technology proved time and time again that the more data we throw at it, the more tools, the AI and ML tools that are out there that we use, the better the results that we got. So at the end of the day, we're current in technology. We get to pilot new stuff all the time, and we're constantly pushing the needle, pushing the envelope to embrace and drive change in our organization and leverage technology to allow us to stay competitive. So, staying current with it, you can't just rest. You can't just implement an AI ML solution and then say, okay, I got it, I'm done, because it can affect so many areas of your business. And so we never stopped since we started.
You're more taking the technology, the machine learning that you've used and applying it to more functions rather than additional types of artificial intelligence.
No, we're doing additional types of artificial intelligence. When things come out, new things come out, new opportunities come out for us that could allow us to do more with less. We do it. The custom vision, the speech recognition, allowing us to build tools that allow people with disabilities to work in our warehouses. These technologies weren't there when we started. And now that they're there, the conversational AI that we're using, it allows us to accelerate our progress and accelerate the impact that IT has on our organization. You have to stay current. So when a new technology comes out, we get lucky and we get to pilot it, and then we look for opportunities where we can take that technology. We've used multiple different types of AI and ML.
Anyone else want to add anything? Otherwise, I'll jump to the next one. All right, next one. Do we use AI as an independent technology, or is it more successful to use it above and with other technologies? Anything from edge processing, big data, cloud computing, et cetera?
I'm happy to take this one.
Sure.
So it really depends on the use case. For some use cases, you need to use it above existing technology. If, again, some of the examples we've given, if you have a robotic arm and you have, sub-millisecond for it to react, this cannot run in the cloud. It has to run at the edge. It really depends. Honestly, I think the more important question to ask in here is, how to start with AI so that it has the path of least resistance. Starting with AI and saying, I'm gonna remove all of these operators off this factory floor, off this line overnight is much heavier of a lift than saying, I'm going to improve an existing process. And that's why we see things like predictive maintenance and defect detection being hero use cases.
I like it. Thanks. Anyone else on that? Otherwise, we'll probably jump to maybe one, maybe two questions. All right. Antonio, this one's actually directed towards you. What are the prerequisites to AI and what can be completed in the interim?
So for me, I think that you have to establish all the data, right? You have to understand the process and get the data that's established. And so not to get really technical, you probably want to clean that data as much as possible. So you can have that to start with. And so I think that once you've established the data historically the best that you can, that's a good step as far as doing whatever it is, because it's somewhat of an open question, not knowing what your use case is. But for sure, you're going to need to have some established data and understanding of where you are in your current state. So I think that would be the best approach before implementing AI, because it's definitely some prerequisites you can do before it even comes. So if you can do that now, whenever it comes by later on, if it's something that you recognize that someone said here, you'll be more advantageous to be able to jump right into it.
Awesome. Lucian, time for one more question, or are we wrapping up?
Absolutely. One more question, please.
All right. Last question is, where did I just have it? Can we use AI for managerial activities such as auditing, performance assessment, matrix development, and what would be a right approach? Who wants to answer that one?
I don't know. I'm not a big fan of doing that. I like the human element, the people element, the recognition and praise, that personal connection, that team concept. And so if I understood the question correctly, I'm sure we will get there. I'm sure it's already being done in some facilities and places, but at the end of the day, that human interaction, that communication, that conversation, it makes people that go that little extra because of who they're working for and where they work. So I don't see us doing that anytime soon. And I'm pretty sure HR would probably not be too excited if we started to do that. So
well, actually, can I beg to differ? I think we have seen AI do some really nice progress, and multiple companies, including Intel, have adopted this. Some job recs, when they were published, were a little alienating to diverse candidates. And we have seen that looking at the language and changing some key elements made some of these recs better. There are a lot of academic studies that have showcased that as well. So there are elements, again, you know, I always think about the value. Why am I here? Why is AI here? It has to bring something to the table that the human is not paying attention to. So even though I 100% agree with you, Tim, about, you know, people management and performance management, but there are areas where, you know, AI could help us understand perhaps biases or, you know, presenting language in a better way.
Awesome. I like two different opposing opinions on the same subject, but yet some common traits. Well, I think that kind of wraps us up. I thank you very much. I was very excited to have you guys as the panelists there. I personally learned a lot through you guys as well.
Thank you.
Thanks, Jeff. Thanks, everybody.
Thank you.
And Lucian, we'll hand it over to you.
Thank you, Jeff, for awesome moderation. And thank you, Rita, Antonio, Tim, and the audience. The next session is going to be in the other Zoom channel, so it should be starting shortly. Look forward to see you soon on the other channel. Thank you, Intel, one more time for sponsoring this session.